How's it going, everybody? In case you haven't heard, Terrence Howard, who is I would say, moderate actor in Hollywood, has also moonlighting as a scientist. and he has no background in science, and it shows. But even then, I mean, people like Rashad Richey have no real background in science, and they can write some really goofy stuff. But this guy goes way beyond that to the point where there are even people calling him insane. Now, a lot of people have been making fun of him. Good. I'm glad for it because, quite frankly, anybody this weird deserves it. But I want to focus instead on what causes people to do these things, going around and telling all kinds of crazy stuff. This is Terrence Howard on the Joe Rogan Show, and put on your seatbelts.
My intention was to rebuild the periodic table, build a new periodic table, because the stuff I had learned in college. I went to school for chemical engineering the first year over at Pratt. And they, at the time, I think it was like 100.
Okay, so he claims that he was studying chemical engineering at Pratt. And in other publications, you'll see where he's talking about the Pratt Institute, which is a college in New York. That's an art and design institute. It's not an engineering institute. I don't know if they even offer chemical engineering there, and I don't know why they would. I don't know what he's talking about. And he wouldn't last 10 minutes in the first course related to chemical engineering.
8 elements. And I told the teacher, the professor, about the relationship between hydrogen on the spectrometer and carbon and silicon and cobalt. And it was like, it's the same exact color, same tone, just doubled in each octave. And he was like, no, each element is the same element and it will always be that element. And I was like, you don't see the relationship. So I left school and I was going to spend 40 years rebuilding a periodic table. And I found out that Walter Russell had already did that. And he did it based upon the natural curvature of everything.
And when you say rebuild the periodic table, what do you mean specifically?
Well, the way the periodic table is laid out, the periodic table they have now,
Let's see.
It looks like a box. It looks like a straight box.
Mm-hmm.
And yeah, you can't have a box. I mean, that's not aesthetic. A box. I mean, that's like 1970s GM, right? I mean, they were making boxy looking cars, and boxy is so boring. Obviously, a box isn't the right shape, but actually, the periodic table, its arrangement is quite clever, and it tells us a lot. So there was probably no need to rebuild the periodic table, but he's going to do it anyway because he likes curvy things, and you'll see why here in a moment. Oh, and by the way, the purpose of the periodic table is largely chemical. It describes how the elements inside the periodic table are likely to interact with each other. The placement of the elements in the periodic table goes according to its electron configuration, how many electrons that it has and in which levels. Because the outer levels of each element largely define the chemical reactions that it can have with other elements. Therefore, its structure, the fact that it's a rectangle or a box, is really quite useful.
They don't show the relationship that between every element, there's two.
All right, here's a periodic table.
You'll see hydrogen sitting all the way over there by itself, but they don't show that hydrogen has the same tone as carbon.
What do you mean by tone?
Same tone, same key of E.
Same key of E. All right, so here is the problem. And I've been talking about this problem with Rashad Richey. This is something that infects a lot of charlatans, misguided individuals. It comes about from the fact that if you have people studying something very hard, and nuclear physics and atomic physics is hard, chemical physics is hard. These are hard subjects. And with that comes a certain amount of notoriety, credibility. People look up to people who understand these things to fairly fundamental levels. Well, those who are on the outside, some of those on the outside crave that kind of notoriety. I mean, you can have a person, for example, here, he's been nominated for, I think, Emmys or Oscars or something. His acting career is pretty reasonable. There's a lot to brag about, and he's looked up to. But there's a certain segment of the population where that's just not enough. And they peer over the fence and they see the scientists and the engineers and their credibility and their notoriety, and they want it bad. Not everybody can be a nuclear engineer. Not everybody can be a solid state physicist. Well, you have to be fairly smart. You have to work very hard, and you have to have a lot of aptitude. And a lot of the musicians, and on the left, let's say, non scientific side, they often lack that. Or even if they had it, even if they had the aptitude to someday become physicists, they don't have the effort. It's a lot of work. You're looking at graduate school, 5, 6 years minimum, but they want it still. So what they do, and this is kind of the gist what I'm getting at, is that they try to take what they know and basically transform that into something they don't know. They don't understand nuclear physics, but they understand sound. They understand tone, especially if you're a musician. If I can understand these, everyday occurrences, music and whatever, and if I can find some way to relate that to these other topics that are way outside my normal intellect, then that means that I can be just like those engineers, just like those scientists. And so they try to find something that the engineers and the scientists talk about that they can relate to. And music is one of those. And the physical property that they latch onto is frequency. They love frequency. And you'll see this in Rashad Richey's book, where it's all about frequency.
Same key of E, 40.5
Oh, I should mention frequency and tone, same thing.
hertz. The next one would be like 81 hertz. You go to silicon, it will double up and would be 162 hertz. You'll go to cobalt, and it'll be 324 hertz. It's based, if you were to take the angles of incidence or the tones that they create, their color. Like you can turn color back into sound based upon, it's the same wavelength, it's just twice as long or much longer. So all you have to do is keep dividing light by 2.
Keep that up, Jamie.
You keep dividing light by 2, and you'll ultimately get back to the audible sound of it, because
he does not understand that the frequencies associated with light that are associated with these elements is on the order of 10 to the 17. In other words, a number with 17 zeros behind it, whereas like sound is maybe on the order of 100. If you're going to divide in half the light frequency to get the sound frequency, you're going to be dividing a lot. Remember, 17 zeros down to 2. All right. There's all kinds of problems with this. The biggest problem with it is that he does not understand that sound frequency and light frequency are completely different things. We know what sound frequency is. If you take the front off your speaker and so you can see the speaker cone and you put it on like a low bass, you can see the speaker cone vibrating back and forth. And how rapidly it vibrates back and forth is the frequency of the sound that it will emit. I have another video where I describe this using a simulation. It's no secret as to what sound frequency is. These are these high-low pressure regions created by the speaker cone going back and forth, and these high-low pressure regions travel and then they hit your eardrum. And because on one side of your eardrum is atmospheric pressure, then this alternating high-low will make your eardrum also fluctuate at the same frequency, and your neural system inside your ear changes that to give you the sensation of sound in your brain. We know what sound waves are. We can simulate them on a computer. We can even see them. There's a very common physics example where you sawdust and then you get these standing waves, and you can see the sawdust lining up along the standing waves. So we can see what frequency is in that way. So now the question is, what is light frequency? Because remember, he's saying you can take your light frequency and you divide it and divide it and divide it, and you get the sound frequency. Well, let me show you. This is Richard Feynman's model of light. If you want to read a fantastic book that anybody can read, if you know how to take the square root of a number, you can read it. The book is called QED by Richard Feynman. Pick up a copy. It's fantastic. A lot of fun, easy reading, not really big, great gift. If you have any friends or nephews or whatever that have a little bit of a science bent and they want to learn about light and all that stuff, get QED by Richard Feynman. Physics is interesting in that physicists are very prideful of their ability to convey very difficult things to the average layman. And Feynman was probably better at it than just about anybody. Okay, him and Carl Bender. But I digress. The question now becomes, what is light? Well, Feynman basically said that you can envision light as a particle. And in fact, he was adamant that light is a particle. And then this particle can be envisioned, and I'm being very careful here. I'm not saying it is. I'm saying it can be envisioned as a clock that rotates as it travels. So as the photon travels to the right, it rotates just like a clock would. And how fast the clock turns is the frequency. That's what Feynman said. So you can think of light as these photons emitted, all spinning. Now you might think, okay, so I know what frequency is, right? I know what sound frequency is, no problem. Light frequency, well, it's the spinning clock. There's only a small problem. This clock spins in complex space, not real space. It has the imaginary and real components. And the clock's value, which is called the probability amplitude, is imaginary valued. So this is an imaginary valued function spinning in imaginary space. Furthermore, the photon has no size, so you can't even envision it spinning. So this is what Feynman was using to describe what light does. And by the way, it's extremely accurate. And it was considered the most accurate physics theory ever created. But can you determine what frequency is from this? No. And most of all, there is no way that you can equate, even with an analogy, the frequency of light with the frequency of sound. They're completely different things. There's another problem with Terrence Howard's idea of taking the light frequencies. Oh, there's a lot of problems with it, but there's another problem. And that is that you can divide this thing down all you want to, let's say, the tone of E, which is I think it's 41.5 hertz, whatever. But the element doesn't make any sound. And the reason why is because you have to have a medium to propagate sound. But the atom is all in empty space. So if you go into outer space and you drop a hammer, you're not going to hear it because there's nothing to carry the sound. Remember, I said that sound waves are high-low pressure regions, and these pressure regions are caused by the movement of gas. But there's no gas around an atom, so atoms don't make sounds. So it's impossible to sort out what he even means. There's all kinds of problems. The other one is he talks about, carbon having a certain tone and whatever the hell that is. And, a hydrogen having a certain tone and one's like 4 times the other. However, that's simply not true. Where does the frequency of light come from in an atom? Well, it's the frequency required of a photon to knock outermost electron out of its orbit. If you look at those frequencies, they don't have any commonality between them and those of the other atoms. You can't multiply 1 by 4 and get the others. He is simply making that up at that point. And this is not Walter Russell going at it. This is him. He's the one that created this whole line of BS that you can get the tone of an atom by taking the light frequency required to ionize it, knock the electron loose, and dividing it down by 2 enough. No, can't do it. He just simply made that up. And that's the one thing about Terrence Howard is, and I'll give him credit, is that as a bullshit artist, he's really quite good. You notice he doesn't stumble much. He lays this thing out. The lies come out of him effortlessly. I didn't even say that right, but good enough. Hey, I've had a little. And that's one of the reasons why he sounds believable to some people. It's because he doesn't hem and haw around. He lays it out. He just keeps motoring on. Okay, so we have here, first to admit that I lack the acumen to articulate complex concepts. That said, I know bullshit when I hear it. Yeah. Okay, let's get back to old Fuzznuts and listen to him some more.
There was a relationship between light and color, sound and tone, matter and shape. I put, I sent over Walter Russell's.
I was trying to get to that. That's what.
Yeah, it's Walter Russell's periodic table that he put together. Now you compare that to what Mendeleev's periodic table. You'll compare Walter Russell's to it, and you'll see something completely different. It's unwinding.
Whoa.
It's unwinding. And you see there's a relationship that hydrogen.
So you had figured this out at a young age?
I had already seen this. This was all inside of that palace. I had access to it, and I knew the relationship.
So you saw this in dreams?
I saw it as a circle. Everything was a full circle laid out, and each area was just expanding, like wrapping a rag around your hand. The first wrap, it's so tight. The very first wrap is so tight. That's the first one that Walter Russell did, yeah. But go back to the wiggly one. This is how I saw it more so, but as a vortex. But you'll see there's a relationship between hydrogen, carbon, silicon, cobalt, rhodium. They're all bonded. They're all sit as the middle point between two noble gases. So those things don't really exist. It's only one substance. Now, the problem is the first thing that we're able to perceive is hydrogen. That's the first visible element, because before it is too dense.
I don't know what he means by visible element. I mean, really, we can see hydrogen before we can see anything else? I mean, the first element that was discovered was copper. And I mean, it certainly wasn't hydrogen. I don't know what he's talking about.
For us to perceive it. You understand what I'm saying?
Okay.
But as you reach into the next octave, the carbon octave, and they call that a bisexual tone, because the carbon has two tones to it. It has a negative side and a positive side. The part where lithium behaves, lithium is contractive. Beryllium is contractive. Boron is contractive. But the moment you get to carbon, you balance it out. It gets.
So another thing that you'll notice from the charlatans is that they spend no effort whatsoever to try to convey this jargon to the layman. A physicist talking to a lay audience would have gone through some trouble to tell the audience what he means by contractive, and would have spent some trouble to try to make it as understandable as possible. But that's the opposite of what these guys do. Rather than taking a certain amount of jargon that you have to be able to convey something accurately, and from that using common everyday words and ideas to make people understand what those mean, they go in the opposite direction. They just increase the amount of jargon. It reminds me of the deconstructionists back in the, like 1980s, 90s or whatever, which was when it was real popular. And deconstructionists would put out these theories. But when you ask them, for example, what do you mean by text? Because they'll talk about, you have to know the text. Well, what do you mean by text? Are you talking about, actual paper, prose, words? And their responses will be more mysterious than when you start it. And you realize after a while that that's what they're going to do every time. Anytime you want a clarification, they're just going to increase the complexity. They're not trying to communicate with you at all. They're trying to sound smart. And this is what this guy is doing. He's trying to sound smart by invoking lots and lots of language. And it's just an example of a person who's just BSing you, really. But it's not impressive at all. It impresses a certain segment of the population, but a seasoned scientist picks up on this pretty quickly.
To a perfect balance of plus and minus 4. So it's a double tone. Then nitrogen is minus 3,1.
Notice he doesn't explain what minus 3 means, what minus 4 is. He just throws the words out there. And part of this is just bluster. One of the defense mechanisms that these guys have is that they throw so much at you that they catch you off guard and you don't know how to respond to it. And so you start to backpedal and you start to wonder, like, okay, I don't think I get it. But instead of stopping and giving you time to think over what they have said, which might raise questions that they cannot answer, they just keep going. And that's another aspect of these guys' character, is their motor mouths. They just spew it out and they keep going. They can't stop, because stopping allows their listener to maybe question what they're saying.
Minus 3, oxygen is minus 2, fluorine is minus 1. Now the balance of this, all of those are mates. Fluorine and lithium naturally mate. If you have lithium bonded with any other element, the moment that fluorine is introduced, it will break all bonds violently so it can bond with fluorine. Same thing with beryllium and oxygen. That's why it said, and what they've tried to keep from us.
Now, I don't know the periodic table to memory, but I don't believe what he's saying is correct. But keep in mind, the whole purpose of the periodic table, well, I wouldn't say the whole purpose, but one of the main uses of the periodic table is to tell us how these different elements bond. And you can tell because one side of the periodic table has basically a lack of valence electrons and the other ones have too many. And so you can look at where they're placed on the periodic table and pretty well predict what the interactions are going to be like. There was no need for this new periodic table for that. The regular periodic table does a very good job of this.
If you want to break water into its component parts of hydrogen and oxygen, all you have to do is introduce beryllium or the sound of beryllium. And oxygen will violently break away from any.
This is easily disprovable. I mean, all you have to do is whatever that sound, that tone of beryllium is, and he's claiming it's a certain number, right? This periodic table that he's crafted from Russell. Wheeler is a very good physicist. I'm sorry. I think he's dead now, but I'm sorry, Wheeler, if you're listening. Right. But at any rate, he's got this tone. Well, just take some water, play that tone on it, and see if this happens. And it doesn't. You got to be kidding me.
Any other thing, even hydrogen, to bond with that beryllium. And now you can have it just with the frequency of it. And since the hydrogen is smaller, hydrogen will, that waveform, you can send that up into one tube, the oxygen into another tube, without using electrolysis, without using heat. It was just through frequency. And the proof of it, if you go back up just a little bit higher, we know the relationship between sodium and chlorine. They're equal and opposite mates. If you get out of the pool and you got chlorine and you're itching from the chlorine, all you have to do is get some real salt and rub that on your skin and it'll turn right into an oil. It naturally neutralizes each other. So everything has an equal and opposite mate. The lithium becomes sodium in the next octave, doubles the same exact tone, just doubled and wider.
What's the opposite of a noble gas? I would like to know that one. Yeah.
The sodium becomes potassium in the next octave, widens up. The reason that arsenic kills us is because our DNA has nitrogen and it has phosphorus in it, because nitrogen unwinds into the next octave right after silicon and becomes phosphorus. Our DNA has both of those in there, but it's going by tone. So the moment arsenic, which sits as a -3 on the next octave, the moment arsenic is introduced, the body thinks that, oh, this is my thing that I need. And it tries to wrap itself around the arsenic, but it causes the DNA to unravel because it's 4 times as large as that nitrogen was. And those other little elements, titanium, vanadium, chromium, manganese, and iron, all of those aren't true elements. Those are isotopes.
Okay, so he almost called it magnesium, caught himself, realized it was not magnesium, but he doesn't know how to pronounce manganese. So he calls it magnesane or whatever. This guy does not know the periodic table. And that's a problem. This is an issue I have with Rashad Richey. It's the same with this guy. They really do think that all of these topics that people look up to, the engineering, the chemistry, the physics, and all that kind of stuff, that really the only difference between those and like history, whatever, is just the amount of effort you have to put in. A person who just pulls off and grabs some, let's say, physics books and just studies hard enough that he'll be a physicist. The trouble is that it ignores the whole idea of aptitude. A musician might not have the aptitude to be a chemist, no matter how much work he puts into it. And there are people who will never be musicians. I mean, they just don't got it, all right? And it doesn't matter how much they practice. It's you have to have a certain aptitude for some of these subjects. And he has no aptitude for physics. If you don't have the aptitude, that means that you have not completed any coursework. And therefore, you don't have the basic building blocks to understand these topics at high levels. If you haven't had tensor algebra, group theory, and all these things, you are not going to understand quantum field theory. There's no way for a person to explain it to you in a way that you will be able to understand it. But they don't get that. They think that quantum field theory and quantum mechanics is all party talk. And that is that, it's a matter of information obtainment. If I read enough and I absorb enough of what I'm reading, I'll get it. No, you won't. You have to have the mathematical background to understand what these things mean. They don't have it. Especially if you think 1 times 1 is equal to 2, you're really behind the curve. That's not a good place to start.
Those things, those first 3 are the full tones. They make full spheres. But now it becomes elliptical with titanium, vanadium, and chromium. And on the other side, it's like when, like I said, if you wrap the rag around your hand, the first wrap, really tight. You can't get much out of it. Second wrap, you damn near can't see the difference of it. Third one, you start seeing hydrogen. The fourth wrap, you see carbon. I need a piece of paper or a rag, and I can show you that twist. But in between each one of them, by the time you get, nature does not allow us in the silicone octave for there to expand out. But there is the same titanium, vanadium, chromium, magnesane, and iron that exists between aluminum and silicone.
Magnesane, he still pronounces it wrong. He doesn't know how to pronounce manganese. I mean, it's one thing if you kind of screw up your talking, right? We all do that. No, he literally does not know how to pronounce the element. And he calls it silicone? No, it's silicon. Silicone is a different substance made from silicon.
But nature doesn't allow us to unravel that. But now, with the wave conjugations, we can. We couldn't do that before because we didn't know the angles of incidence that were necessary to open these things up.
So another one that he's come across is wave conjugation. What he's probably read was wave function conjugation. With the wave function of an atom, which is just the probability of amplitude for finding that particular particle at a certain point in space and time. Probability amplitude, not probability. Probability amplitude is complex valued. And the complex conjugate is you have a complex valued function where you replace I, the imaginary number, with negative I. Okay, that's called conjugation. So the wave conjugate is the wave function, but with the I replaced with negative I. That's really common. Okay, you see it in quantum mechanics books all the time. He doesn't understand what that means, but he loves the vocabulary. So he talks wave conjugation. He doesn't know what he's talking about.